This video is about installing a brand new electric water heater where you had none before. What this would entail would be to cut into your cold water line and solder a new connection like this with a valve. If you didn't have a thermal expansion tank, you would need to also add that part as well. And then you would have a flex copper connectors going up, cut into the hot water line. And then again, if you're swapping it out, that's easy. You would just take these off, put in the new water heater and connect these, which I'll show you how to do in the video. And then in my case, I soldered a new elbow here, put on this connection. I had to put a new 30 amp breaker for the power. It wasn't too difficult. I had space for it. I added the 10 gauge Romex that goes over to the service panel. I don't need a shut-off switch because I can see the service panel. I'll go through all these things in the video. If you want a 2-minute video on how to install a water heater, there's plenty of those. But in this video, hopefully little tips and tricks can help you out. I tend to explain every little thing about the parts, the tools, the procedures, the codes, and how everything works. But look down in the video, you can see the different chapters. You can skip ahead if you want, especially if you are not installing a brand new water heater. You may want to just see how to swap one out. In that case, you can see especially the second half of the video where I install the water heater. This is a 40-gallon water heater. Just brought it down. I recommend 2 people lifting this thing. Personally, I did it myself using a hand cart, hand truck, whatever you call it. If you're gonna do that, these 21-inch rubber straps connected to the back of this and worked perfectly to tighten and hold the water heater onto the hand cart. There's 2 important things you have to do when you're bringing something down steps like this, is to hold it down and hold it up. Every time you go over a step, it's going to want to flip forward. So that's when you got to hold it up in the direction of upstairs and down so it doesn't flip. And with tires this size, really just has to roll over quickly, and then you hold it so it's a soft landing with each step. I don't recommend that, but that's how I did it. So now you have to figure out copper. I have 1/2 inch copper, but I'm going to be putting, these are 3/4 inch inlet outlet. It'll have a 3/4 inch thread, and I'll have a water heater connectors, flexible. They're not required by code here, but and make it easier to replace it in the future. I also have this 2-gallon expansion tank. It's a thermal expansion tank. It can be pretty much anywhere on the plumbing, but it has to be if you have any kind of pressure regulators or backflow preventers. In some cases, your meter will be a backflow preventer. It's a check valve. It only allows water in one way. So if water expands even just a little bit and there's no faucet open, without these it could just expand backwards into the system. But if you have anything like that, that's a closed system, you're going to want to have an expansion tank. This one here, it has a little rubber bladder in there, and it will expand into the air part when the water expands. That's another safety measure, because this temperature and pressure release valve, if this doesn't work and you don't have an expansion tank, you can either cause leaks, you can damage your water heater, or it could even explode. So it can be pretty much anywhere. In my state, I didn't see any requirements of where it needs to be. It just needs to be somewhere between the water heater and those valves that I said. That's it. but I'm going to put it right next to it. A lot of people use brass fittings, but I don't think that's necessary as long as you're going to use a strap. So what I intend to do is to have a 3/4 inch female threads here. 3/4 inch female threads here, so I have a lot of soldering to do, a lot of cutting to do. I'm going to be putting the valve, and then a T, which will go over to this, and then that will hang. There'll be straps holding the copper up. There'll also be straps holding the tank up, because it can get pretty heavy. Remember, if these threads ever leak, or if this whole thing snaps off, then you'll have a flood, because the water is going to keep going. The cold water line is just going to keep flowing into that leak. That's why a lot of people don't put it horizontally, although you can, especially if you're going to put straps up. But it's best to either have it going up or down, because it's not going to turn. It's not going to want to snap off. You're supposed to make it a little bit higher pressure than the pressure in your system, and it's going to go down slowly over time. This is a pressure valve, air valve, similar to a bike. You can use one of these if you're only going to add like a couple of pounds, a couple of psi. But this measures 40 from the factory, and my system is 60 psi. So I'm probably going to hook it up to my compressor, my air compressor. Otherwise, it might take a while to get this on. But yeah, so you're supposed to do that before you put the water in. There are ways to add air to it if you already have one of these and you use like a bicycle, not a bicycle, a tire. So yeah, it's already down to like 35. You can use one of these. There's all kinds of different gauges that you can figure out. You could empty your water tank, close off the cold water valve, and then you could open a hot water faucet so you can add air to it, so pressure goes out the hot water faucet. You can drain your tank a little bit if you're going to add. But I'm going to be adding a new expansion tank where there was none before. So a lot of you may already have one, and then it's very easy. You can just buy one, either like 20-30 bucks for the 2-gallon one. Put some Teflon over there, put some dope over the threads, and then just thread it and tighten it. If you look closely, it's kind of hard to see, but you have a little space here for your wrench. So once you get it hand tightened, then you can tighten it a little bit further. I have to solder these connections where there was no piping before. It was not easy to get it into the pan. It takes a lot of rolling back and forth, but there are ways you can do it by yourself. I have to do all of the electric. I'm permitted. I have a permit from my local township, and they are allowing me to do the electric. I got to get 10 gauge over from the electric panel right there over to here, and then it's going to go down, connect to the 10 gauge connections here. 240 volts. It's 120 volts each. So there's no neutral, but there is a ground. So you'll have to ground that. Because I'm within sight of my electric panel, I don't need a shut-off valve here. There's really kind of debate whether or not a basement like this really even requires a connection like a metallic connection or a flex connector. I'm probably going to buy the flex connector, and otherwise I don't know, you might get away with putting Romex directly down, but I'm going to, the permit was only 37 bucks, but I'd rather not have to pay it again if I fail, and I'd rather not have to take more time. So I hope to do everything right the first time. So yeah, I'm going to cut in here. This was my boiler. Boiler started to, I guess you can't really see it. Boiler started to leak, especially around the gasket. It's old enough that I may as well just try to replace it. So for heat, I might have to do something like electric heat. I'm not really sure, but your situation will vary. You may already have a water heater. If you're watching this, in that case, it's very easy. Then you're just gonna shut the power off first. Then you're gonna shut the water off, drain it, undo the connections, put a new one in. There's really nothing to it, but adding a new one, I'm gonna have to cut. I'm gonna have to cut where the hot water was coming from my boiler, my combi boiler, the coil, which I'm no longer gonna use. I'm probably still gonna use this for heat if it stops leaking, if my little temporary gasket works. But like I said, your situation will obviously vary. But I'm going to cut a T into the cold water line, come down, have another T come over, and have the water, the thermal expansion tank right here, right under this stud, so I can put straps like this and hold it up right there on the stud. So that should be perfect. This steel expansion tank is a different kind. It's not a, it doesn't have a bladder in it. It just fills up halfway and then expands. And then over the years you can drain it, shut off the valve, drain it, and then the pressure it'll fill automatically, you know. So yeah, but I don't need that anymore. And that's disconnected right now for the rest of my system, so it doesn't help me with the thermal expansion. So a new one, it is only 30 bucks. So yeah, so I'm going to show you how I did it. Now I'm going to put electric water heater. You can use a hacksaw if you want to cut copper lengths that you're going to assemble, or you can use a tubing cutter. It's got a little wheel in there. It can start to get kind of dull, and you can replace that wheel by unscrewing this. And so I have it marked here. What you can do is you can just put this over the mark. And the way it works is that this keeps tightening. Every time you spin it, you tighten it a little bit more. Spin it, tighten it, spin it, tighten it, and that will cut the pipes. These little things are really handy when you're cutting pipes. Like when I have to cut these pipes, there isn't much room for a saw or anything. So definitely going to be using this for cutting into the existing pipes as well. So these little wheels, I center it. Basically you have that. So you'll see there's two little wheels. They center the pipe, and then this will cut where you mark. Mine didn't have to be very precise. So then you tighten it, spin it. Keep tightening it by hand. This has definitely been used quite a bit, so I'm gonna, might take a little longer if you have a dull blade. When it starts to get easy to turn, then you know you should tighten it down even more. And then I'm going to do as much soldering as I can down, so I can get about half of the soldering or so done first, just to make it easier. So when I assemble everything, it will be easier to solder just a few connections when it's all up. So you're going to really crank down on it, tighten it, spin it. There are ones you can buy that do this automatically and make it much quicker. You can use a file to make sure there's no burrs on the outside. And then a deburring tool, which I have to deburr the inside. See all that? This will cause a pinhole leak if you leave them in. You gotta get rid of that. If you don't have a tool like this, you can use anything that will just scrape off, for example, like a wrench or something. Or the edge of this wrench is doing a similar job. And then the outside, clean it with sandpaper. I like to use steel wool on pretty much both connections to clean it and get it ready for flux and solder. Just clean it as far as the actual fitting will go. I don't really need to clean it much further than that. A quick note on these fittings, these 3/4 inch fittings here. These are the fittings that are going to connect to the copper. In my case, this is a reducer, 3/4 down to 1/2, or you may also have 3/4 inch male threads to the 3/4 inch solder connection here. This one I'm going to be using for the temperature and relief valve. I just have to get the 3/4 inch pipe for that. But with either case, well, not really in this one. That's not pressurized. That's supposed to almost never open. But where you're connecting your water, hot and cold, you're going to be using, you're either going to solder the connection, or you're going to be using some kind of a flex connector. Those have washers, rubber washers in them, and that's how it makes the watertight seal. It's not a beveled connection on the inside that gets tightened. You only need to tighten it enough so that the rubber is pressed up against this part. However, when it comes from the factory, this could be really rough. So I just rubbed it back and forth on my concrete subfloor here in my basement, just as kind of like a rough rasp, if you will. And then I took a regular file to the top, being sure to turn it as I go, because you don't want it to be, crooked, and then you have a problem, because the threads are going to go all the way up here and then push down flat, square, up against this part here. But you want a nice flat edge for the rubber washers to make a nice flat, square connection. So you can see already, I don't know if you can see that, but you can rub your finger on it like that and you don't get cut. Then you know the rubber is not going to get cut, and it's going to make a nice seal. So everything's set up, so I can solder this part here. When I solder, this is for the cold. This will be where the cold comes in. This is where the cold goes to the boiler. This will be the shutoff valve for the water heater. The water will flow down to the water heater. But if the water ever expands, it will go down here to where the tank is, the thermal expansion tank, which will screw right into there in an easy to access spot. I will have a strap here and larger straps holding the tank, so it won't be any problem, because these aren't really, they're not structural. I'll also be using copper brackets, so it's metal, same kind of metal. Once I have all this soldered, then I can cut and put this up on the water line, which I've already cleaned with sandpaper and steel wool. And then I will just put this in there. Hopefully there's enough flex, because they're like flexible copper tubes that I can pull down, and I won't have to put a slip coupling, hopefully. And then I can put each side into there and then just solder that. Keep this open, steam will just blow right down there or here. And then that's gonna go right here. I don't know if you can see that. This is the hot, this is the cold. This is already cleaned. This is where the cold is gonna go. The valve will be accessible right here, and the expansion tank right here. And then from here to up there will be a flexible connection. I have to figure out which sizes are available. I want to get the right size so I can actually adjust that piece of copper. Alright, this is just dry fit, so I have to brush flux on each side, each piece, and inside each fitting. And then I can solder this piece, and then I'll attach this part up at the cold water line, and then I will just solder that while I'll put up some string or something to support the weight, and then solder that. One important thing for this particular apparatus is to make sure this is going the same direction as that. So when I put this up, this will be the expansion tank will be directly under that, and I have a little bit of clearance over to the concrete wall, the chimney there. And if I put that like that, and then this will not have clearance. So obviously you want to be able to take that on and off. So let's get to soldering. Alright, that part is soldered. It should go without saying that when I put everything together and hook everything up. And what I'll do is I'll turn on the water and check for leaks. And as far as soldering, still have to solder the copper 3/4 inch. The 3/4 inch copper will be the temperature and relief valve of discharge tube. It's not pressurized. It actually has an air gap no more than 6 inches above the ground. And because of the pan, I'm going to have two 45s kind of jutted out a little bit. And code says it has to be the same size as the relief valve, so I can't reduce it like I have here. So I can't reduce it down to 1/2 inch. I was running out of 1/2 inch pipe anyway, so yeah, that cost like $60 for two of those, or no, yeah, like $60. Would cost more for a longer one, I guess. But okay, now time to cut. I have it marked here. This is the hot water. I have the hot water off, drained as low as I could, and the faucet, there's really no other way to drain it. This is a flexible copper line, so it has kind of ridges and valleys, so it's almost certainly going to be some water in this, so hopefully it won't spray out at me. I was going to try to use a hacksaw, but it seems like the cold water line would be in the way. and so would the radiator line anyway. So I'm going to attempt to use the tubing cutter. There's the hot water line. You can use a tool like this to easily clean the outside of it. Pushes in just about the ½ inch size of the fitting, and then use a deburring tool to go around the inside of it to get off any burrs. You can also use some tools have these little, this is a Milwaukee, looks like a Milwaukee. It's got a, this is pliers for perfect size for hex screws, adjustable. And it has these little parts in the end that you can put into pipes to deburr on the inside. This thing can be really difficult, but it's here for exactly this reason. I couldn't fit a hacksaw in there or any kind of other saw. Possibly a Sawzall electric. Maybe I'll actually do that for this. But yeah, you just, for this I couldn't even go all the way around it. I had to do it in parts, just little by little, and then take it off, put it on the other side because these pipes kept getting in the way. So do what you have to do. And plus this is getting kind of dull. I'm gonna have to replace that blade or just buy a new one eventually. And the thicker the copper, the longer it takes, of course. But so I'm gonna get this soldered on. This is for the hot water outlet. I'm not even gonna bother with a valve because the cold water will have the valve. Try this pump. It's got this little tube. Comes out this way. You can put it up to a garden hose. I'm going to see if I can get out some of the water. I don't know if that did much, but some of that water out. Black. Water is completely black. Now I'm going to put flux on that. I spritz this really old dry wood with water. I'm going to spray it again so it soaks it up. And then I'm going to put aluminum foil here as a heat barrier and then hit it with the torch right here and put the solder from the other side. Put the aluminum foil in place, spritz that with water, a little bit of water here. Tried this new tinning flux. So that's a lot, maybe a little bit much of solder there. So this tinning flux has solder flakes or solder powder in it. So it really helps to make a good seal. Hopefully this residual water that keeps dripping out will not make this too cold. So I have a nice new torch with a trigger. I'm gonna put it up there. Heat it up from this side and then apply the solder right there. This got warm, so this was really helpful. Alright, so this is just dry fit. This is my cold line. It's where the expansion tank's going to go. I'm making sure that it's in line here and not turned closer to the chimney here. Plenty of room for the expansion tank. This is just temporary. I'm eventually going to get straps laterally, probably holding up the tank to here. I don't know about probably, but possibly. I need to be able to take it out easily as well. This is just holding this up. Once again, I sprayed up there with a little bit of water. Put this heat shield for the cables there. And I'm going to apply tinning flux on all three of those spots. And I intend to hit up the vertical spot first. And then this side and then that side. So hopefully all three connections can be done quickly. This is a ball valve, so I'm not worried about any rubber melting or anything like that. Steam should just go straight down. And I don't have a persistent drip as much as I did on the hot water tank, hot water line, which is over here. That water still comes down a little bit. So, I don't know, sometimes you can't really know for sure until you test it. You can always take it off. So, let me get to soldering. So yeah, problem is when water keeps dripping down, it has a cooling effect on the pipes. But I was able to heat it up again, and that looks pretty good. Probably don't need to show you how to put on Teflon tape. Just wrap it around clockwise. Remember, when it's upside down, clockwise. Make sure when you're looking up, clockwise. And then I use this thread sealant. It's good for potable water. So it's good for drinking water, and it can be used on plastic, metal, whatever. And it's great for, it is a sealant, but it's great for making sure that there's a smooth connection. All four of these connections have washers. So you really don't have to tighten these particular ones really hard. If you have a compression fitting on the other end, in other words, you just had pipe that terminated, like a 3/4 inch copper pipe that just terminated right here. You can buy these connection lines in a kit, and it comes with a compression nut. So that pipe would just fit right in there. This particular one that I have goes down, adapts to 1/2 inch, but if you're going to use something like this, it might be a 3/4 inch on one side and then a 3/4 inch on the other for smooth copper. Has this compression ring, and then you put this nut in first over the pipe and then the ring, and then that will tighten. Put a little pipe dope, same stuff, around on the inside and the outside of the ring, because when it turns, it'll smoothly turn without any issue whatsoever. It won't get snagged up. And then you tighten that down fairly tight, and then you'll tighten that. But these have washers, so they don't have to be that tight. They just have to make sure that washer is pressing up against that copper at a nice watertight seal. All right, now for the expansion tank, same thing. It'll be Teflon tape and then pipe dope. And then on here you see there's a spot for your wrench right there, so then you can tighten it even further. And there's just a little rubber in there. You can see that. This only expands when the heat expands the water. And if you have a dripping T&P valve, temperature and pressure valve, it could be because this isn't properly pressurized, which I still have to do for this. And what you do is, this is just like a regular bicycle valve, but that might take a while because this is pressurized at the factory at 40 psi. I have to get it up to just over 60 psi. Tire inflator gauge goes onto your compressor. You can leave a link on this in the description. And I'm trying to get 60, a little bit like 65 psi, because a few psi is going to come off when I take this thing off and test it. And you want it a little bit over 60 anyway. Okay, I just had to set my regulator, was set too low. So here we go. You can hear the air going in. I'm at 57. 55, so that's no good. So I'm going to try to go a little higher in case this gauge is off. I also could have lost a lot of psi when I took the piece off. Just has to be over 60. This thing is pressurized. If it leaks from there, I can always tighten it. I don't want to over tighten it. Alright, so I'm ready to, just so you know, so that's the temperature and relief valve. I'm going to put a 3/4 inch copper down there. Code says it has to be the same size the whole way. It just has to terminate 6 inches above the floor. No more than 6 inches above the floor, but it has to have an air gap. Ideally there'd be a drain here, but there's a drain down in the middle of the room. For me, this is not supposed to open. If it does, then there's too much temperature, too much pressure. That's what the expansion tank is for. It's got that little bladder in it. When it fills with water, it's only going to fill about halfway, and then the air will stay there. This could be either down or up or horizontal. The problem with horizontal though is if it fills with water, it gets very heavy and then it can snap at the threads, and then that water, remember this is your cold water line, there's nothing stopping all of the water to go into your basement or your closet or whatever. So at least it's up and down. I wanted these flex lines so I couldn't have this situation up. I couldn't have it facing up because I wanted to have this flex line here. And so I just soldered these, so I'm going to be testing. First I'll have this shut, I'll test these. Still have water going to my boiler for radiator heat. These just have rubber washers in them. You could get a dielectric union. I couldn't find one. I would have bought it if I couldn't find it at the store both times I went. So I'm hoping that just this copper and then brass. Brass is better than just going copper to steel, because that will cause a galvanic corrosion. This still may. I'll just keep an eye on it. Brass is much better. And then here, same thing. So this is just going copper to brass to copper, so that's no problem. But here, these may not be dielectric. And so hot water, pushing the air out. I have checked for any leaks in my connections anywhere. Expansion tank is up. I don't have any leaks. Tiny leak down there. Let's just tighten that up. Copper connections. So you leave the hot faucet open upstairs to push out all the air as this fills up with water. Just about full. Kind of hear it. Okay, so we're testing for leaks, filling the water it will eventually fill up, and then tomorrow I can make the electrical connections. And then when I flip that breaker on, this will be on, and these elements will start. They need to be filled with water first before I could do that. So that's why I'm filling this up right now. So far, so good. You have an electric water heater. Today you're going to make a very easy connection. If you're just swapping your heater out, then this will be very easy, because then you basically will just turn the power off. Obviously, make sure the power is off. And then your wires, you will hopefully already have a cable or a conduit or something already coming down from the other water heater. And then you will just simply attach. You will twist the bare conductors, the copper, together. This is black and red, but your cable may be white and black. You could use either one. It's just good practice to label the white black everywhere it comes in and goes out, to make sure that there's no confusion that these are both hot wires, because this is a 240 volt appliance. And in my case, I am installing a new water heater, so I had to I still have to install the new breaker and then run this cable, this brand new cable over here to this new appliance, because my boiler has a 120 volt shut off there, so that doesn't really help me. So, and I don't need a shut off because I have the breaker, the service panel within sight. Ground connected, the green screw, wire nuts tight. Pull. You have a good pull on them to make sure they don't come off. If they come off, then it's not connected. Right? Then you just have to push these down into there, put this over, and then tighten this down. Okay, got the cable tightened down. Cable going straight up to a junction box. And then from here, ground will come in. The cable will come in here. Ground will ground the junction box itself, plus connect to the ground to the water heater down here. Those connections are already made. And then we'll have the black and white connect to the black and white again. And then that cable will go through to the service panel, to the breaker. I'm going to install this 30 amp double pole breaker into my service panel / breaker box. I'm going to install this 30 amp double pole breaker into my service panel / breaker box. I'm going to be doing that today. I'm going to be cutting off the main power just to be extra safe. I have a 10 gauge cable coming through the studs, the joists for my new water heater over here. I have just enough length, and I'm going to be cutting somewhere along here and then putting a cable connector right here. I'm going to tap out that little circle there, and then I'm going to have cables go to the ground, and then this is both hot wires, 240 volts. too much coming through, just a little bit. Come here. And handy here. Position that kind back there. And you see what I did there, kind of off camera, was I took this ground wire, this ground conductor here, this copper, okay, and I put it in one of the available spots in this neutral ground bar, this bus bar, okay. Now it's loosened, so all I have to do is take my Robertson screwdriver and tighten that down. Always give it a tug. That's not going anywhere. Alright, so that's it for the ground wire. The moment you've been waiting for. All I did was route the black and white cables, the wires, to the other side. Okay, that's something that can be done. There's no problem with that. It's out of the way. And if you'll see, you can barely see it probably, but it says strip gauge there. Strip gauge, so you're only supposed to strip just that amount, which is what I've done. And I put black just so everybody knows that these are supposed to be both hot wires, both hot conductors. So this is off. Okay, double check that anyway. You can always double check. This is off, power on to it. It's got these little tabs. It might be different for a different brand. It might be slightly different. It's got these little tabs that go in there. These are somewhat out of the way. And then it just snaps into place. Okay, you can barely see back there where the copper is going to meet. And then, okay, it can be a little loose, but this isn't loose at all. That's fine. Enough so you can't pull it out. Got these helpful little tabs so that one person can do this. It holds up the cover. Last thing to do is just right down there, water heater.